linear solution, just using the simple dynamic top-down programming approach using memoization. Although we have solved this using the top-down approach, I think we can also approach the same problem using the bottom-up approach. So there are two, you can say the flavors or the recipes of dynamic programming. One is top-down, one is bottom-up. Bottom is very much intuitive and it's very easy to understand. So bottom-up is very much similar to this, that however we calculated this in the Excel function, that this is the sum of the previous two numbers. So we start with, say, for example, I have got dp here, and it would be using the starting with the 0, dp0 is 0, dp0 is 1, and then we already have that for the dp to equal to dp2, it would be the sum of previous. So it's exactly the same that what we are going to do in the formula here. Now let's code it down. Again, I will create a simple, maybe I'll just copy this and change this method later on. This is the bottom-up approach. For bottom-up, and just let's remove this. So as discussed, I think the base condition in all the three recursive top-down should be same here as well. So here again, I will create it will be long again, and we'll still store it as a DP, and it would be new long n, right? So, and the base cases for dp0 would be 0, dp1 would be 1, and let's calculate for the remaining from starting from 2 to the number n. So here we are just using the same formula as we used in the Excel. So it should be dpi, that is starting from 2 to the n, to dpi minus 1 plus dpi minus 2. And then finally, we simply return dp n minus 1 plus dp n minus 2. Okay, so let's test how this the performance is. Again, because we are just calculating it, calculating for each Fibonacci number once. So the time complexity would be again same as top-down approach, which is O(n). So let's run this. Okay, so we see that it's quite quick, just like the top-down approach. 21 milliseconds for the first time because of the JVM warm-up. And even for 50, it's quite quick. It just takes 3 milliseconds. Other 40 and 30 are too less. So it's just less than the 0 milliseconds. It would be some nanoseconds. So this is the way, we just checked that just using the dynamic programming approach, how we can solve a very complex recursive, having the complexity in polynomial back to the linear using the top-down approach and alternatively the bottom-up approach. So that's it, friend, for this very basic introduction of dynamic programming problems with using the Fibonacci numbers. And we have seen that how drastically the dynamic programming approach can solve the recursive problems into much, much better time complexities. Now, for the next tutorials, we will keep on solving the various popular problems in dynamic programming, and we'll start with the longest common subsequence in our next video. Stay tuned.